Welcome back to the bench and this special episode of Ground Tinkers. This episode is being filmed in cooperation with Transmission 64 Demo Party, and it will be broadcast on their channel and later afterwards on the usual channel. What we're looking at today is C64 power supplies, and then looking at some C64 boards and going through some common faults that these boards have. With the power supplies, we've got the good, we've got the bad, and we've got the ugly. This is my favourite type of power supply, and I'll tell you why in a minute. These are definitely deserve the name the Brick of Death. Technically they all come under that heading, but this one truly is a brick. It is completely potted, it is solid. This thing probably weighs best part of 3/4 of a kilo. Yeah. These are the steep slopey wedges, I call them. It's another common type. And then the short slopey wedges. The reason these are my favourite is they can be repaired. They are still potted, however, you'll notice it has screws on the bottom, and if we quickly whip the bottom off, we will see what I mean. Screws drop out. So you can see that it is potted, but it's in two sections, and this section here is only very lightly potted, so it is actually possible to get this out. You can see I've already repaired this one, and if you want to know how to do that, there is a full video on that on my channel. Basically what I did is I designed a board which is pretty much a drop-in replacement. So you salvage the fuse holders off the old board, and then the rest all new components and a slightly better spec regulator, drop it in, bit of extra potting compound, new stuff, and then Bob's your uncle, sells your aunt, job done. These ones are totally unrepairable. When these go bad, they're just junk. Some people do take the bottoms off and then pull the whole lump out and then reuse the case and put a new power supply in there. It's not possible to get to the old one. Anything that you could put on there to dissolve the potting compound would just damage the transformer, so it's a waste of time. These ones, again, they are potted, but it's in two compartments. The transformer is here and it's potted along with the voltage regulator, and then the board sticks out along here. So in theory you could just cut around the potting, get rid of the old regulator, put a new one in, and maybe something similar like this in order to reuse it. Usually the transformers in these don't go bad. There's not much to go wrong. It's a couple of big coils on a piece of metal. It's usually the voltage regulators that die. What I have here is just a little quick test that I did, a quick test board. So we take this, we can plug it in, and we can see we've got 5 volts and we got our AC 10 volts. And then there's a couple of points on there where we can just hook up a meter and we can check our voltages. Now when the voltage regulators on these go bad, 9 out of 10 times they fail shorted, which means that they send the full 10 volts right through your C64. So we can see that this one is outputting 5.919 volts, which is okay, definitely within acceptable. And then here I just have a load resistor which I can just quickly switch in, and then I can see, okay, under a load, 1 amp load, it'll drop down to 5 volts. So this power supply at the moment is good, but it might not stay that way. There's also a couple of pins there we can test the AC voltage, but usually that's not a problem on these. It's just a straight tap off the transformer. We have our brick of death, and we plug this in, and right away we can see we have no 5 volts. So not having 5 volts is better than having a shorted regulator, because at least when this one died it didn't take the C64 with it, so that one was probably still good. And lastly, my revamped one. So 5.24, it's a little on the high side. Could probably do with it a little bit lower, but it's not going to hurt the C64 because as soon as we put it under load, it drops down to 5.06, which is more than acceptable. There are devices out there, they're called C64 Savers. I'll drop in an image. BWAC makes them. He's done a pretty sophisticated one, and what that does is you just literally just plug it into your power supply in one end, plug the other end into your C64, and if your power supply does go bad, then it stops any dangerous overvoltage that could fry your C64. If you're on the lookout for a replacement power supply that you want, so you can keep things, your setup looking original, then these ones are by far the best ones to go for, because yeah, they can be easily repaired. The only other alternative then is, if you're not too worried about having a non-matching power supply, is just buy a aftermarket one. There are several available on eBay, or you can even hack together one yourself. I've seen somebody hack one together using a couple of an AC wall wart and a 5 volt wall wart, and just slap them in a case and screw it shut, and job done with a bit of wiring. One thing you can do with these ones is, if you do pop the tops off, is take the cables out, because obviously if you want to build your own power supply, reusing the cable is a good idea because you've already got the plugs on. These may be the worst power supplies for failing, but the good thing is that they have these nice molded plugs on there, not like these ones which use these horrible 2 half shell ones. Same here. So for that reason, these ones are good, even if you can pick one up that's bad, just so you can salvage the cable off it. It's a lot easier than making up your own. Okay, so we've got 2 C64 bread bins on the bench. They're the same model, same motherboard revision. Both of these had or has faults. This first one here, let's take a look at this one. Turn it away. This is one I picked up off eBay, and this is a 250407 board. And when I received it, the 2 6526s and also the Sid Chip were missing. So I borrowed some out of a donor board, put them in. I mean, you don't actually need these to test the board or the SID. The board will work without them and boot. And the board didn't boot, so I used a dead test card. which gives a series of flashes if there is a RAM fault to indicate the RAM fault. And for this board, sure enough, it had a RAM fault. So as you can see here, I socketed all the RAM chips and removed them. The ones that were in it were these things. These are, focuses, MT branded RAM, and or I could even put it here in front of this one. No, it's not going to see it, too dark. And this stuff is notorious for going bad. Basically, if you have a C64, when you turn it on, you get a black screen, i.e. the video signal is detected, but you get a black screen and you see MT RAM chips in there. Then a lot of averages are that one or more of the chips will be bad. And yeah, even if they do work, it's actually a good idea to replace them because they will eventually go bad. That's pretty much guaranteed. From what I understand and read online, MT had an issue during the production of a lot of these chips, so they actually degrade over time. It's not a case of will they go bad, it's a case of when they will go bad. So that is one common fault on these machines. I replaced these with some NEC branded chips. If you see other branded chips, I mean, it is possible that they go faulty, but when that happens, sometimes it can only be one chip that's faulty, whereas with the MT, you could have half of them faulty, if not all of them. I think in this case, I think 6 of the chips were faulty when I tested them. If you want to test these kind of chips yourself, it's actually quite easy to do. All you need is like a Arduino Nano or something like that, and a breadboard, and you just hook up some wires, and you can get some code that will run on it, and it'll just test the RAM. It's a nice cheap way of doing it. A couple of euros, a couple of dollars for a Nano and a few bits of wire, you know, it's not going to cost the earth. One of the other things that does go bad on these quite often not is this chip here, the PLA chip. The MOS chips are notorious for going bad over time. They did have other companies produce them. Signetics, if I pronounce that correctly, did a PLA chip, and those ones are pretty reliable. So if you see those, then you're pretty much guaranteed that it's going to work. It's not going to be a problem. This thing all runs fine, but this PLA chip does work, but it's marginal. So if you run software, it seems to work fine, but if you run, even if you run the diagnostics cartridge, it actually passes all the tests, but if you try and run dead test on it, it'll actually indicate a RAM fault, and that's because it's not able to probably detect the RAM because this chip is probably not quite up to spec. And we can take a look at that in a moment when we have a look at the diagnostic cartridge. For now, we'll just pop the lid back on this. Somebody fitted a mod to this, which is kind of a bit sad. I mean, if they'd put it on the back, it would have looked a lot better. It's just a reset switch. This is another one with the same revision board. I won't bother unplugging the keyboard this time. Quite a lot of the chips in there I did socket off some of them for ease of use. It has the 6581 Sid chip. The Sid chips, unfortunately, they also go bad. Usually the actual sound chips themselves carry on working, but it's the filters that are built into the chips, they tend to go bad, and once they go bad, that's it. On this board, obviously the RAM is here and it's not MT branded, so that works fine. There's no issues with that. Most of the other, like the basic, the character ROM and the kernel ROM, they're not MOS branded chips, but the rest are. This PLA works absolutely fine. With their test, it'll run normally, no issues. But where this one fails is on this 6526 chip. So the machine seems to work perfectly fine, and then but as soon as you try and run their test, it'll come up with U2 as an error. So even if you see somebody on eBay selling one and they're saying, yeah, it's tested, it works fine, you know, you can see a picture of the screen and some writing on there, that's no guarantee that it's going to be any good. For a start, you can't even tell if the Sid chip is working from a picture, obviously, or even if there is one there. A lot of times people will buy these just to pillage the Sid chips because they go for 40, 50, 60 euros on eBay at the moment. Unfortunately, a lot of people just buy these machines just to break them down and scrap them because they can make more money selling them as parts than they can sell them as a whole machine, which is something I'm totally against. We should preserve as many of these old machines as possible, and that's why I own, I think, 3 bread bins and a couple of C models, as well as various other Commodores. I recently picked up 2 C16s for a pretty good price, and I have a whole bunch of 128s. So we'll give this a test also in a bit. With the Sid chip, this is a SwinSid, which is basically, it's just an Atmel microcontroller that basically does its best to simulate a Sid chip. It's not the best solution in the world, but it's better than nothing, that's for certain. As long as you're not a purist, if you've got a C64 with a bad or missing Sid, then you know you don't want to spend too much money, because maybe you play a few games on it here and there. This is a good alternative. There are ones like the ARM Sid where it's supposedly almost identical to a real Sid. There's hardly any difference in it. If you use it a lot and you really want to get as close as possible, then that would be a solution. With the PLAs, there are various solutions to replace that. Certain types of EEPROMs can be programmed to work in place of a Sid, which are generally not 100% compatible, but compatible enough for most things. But also there's things like the Plankton, and there is a new one available using a CPLD. I can't remember the name of it. I can probably put a message up on the bottom of the screen with more details of that. So let's get this hooked up to some power and check it out and see what we get. That's power, so no good plugging that into the video port. That'd ruin your day if it fitted. Okay, and as we can see, we get a nice reasonably clear screen. I mean, yeah, you've got the jail bars on there. That's a common fault with all these or not so much a fault, but an issue with all these C64s. Some are better than others. This one's not too bad, so you know, I haven't tried to fit any kind of S-video mod or replacement for the modulator in there. I don't see the point. So let's break out the dead test. So we've got, for the cassette port, we've got the actual diagnostics ROM, which is 4 different diagnostics in one. We have the user port cartridge. This plugs into the IEC port, and then we have the cables and the keyboard connector. These are produced by a guy down in the south part of Germany, Sven Peterson. He does quite a few projects for the C64 VIC-20. I recently picked these up off him, and yeah, they are a fantastic tool to have. As I said, both these have minor faults on them, which are completely not detectable when using the machine. So let's get these hooked up and we will run some diagnostics. Oh, I might as well pop the lid off because obviously we need to plug in the keyboard dongle. I think the cartridge can go on a bit further once. I think it's sliding forwards a little bit. Okay, so here is our keyboard. Okay, so control port 1. Control port 2. Helps if I plug it in the right way. Okay, and this is for our cassette interface. Okay, and then using the switches on the side, we can choose set 1 and set 2. So we want set 1, which is down here, and then we want the first of all the diagnostics. And contact. Okay, so it's now testing the RAM, 0-page stack is fine. It's testing the screen RAM. That's fine. RAM test 1. Okay. Number 2. Come on. That's okay. PLA test is okay. And now it's silencing the color RAM. I'm not sure what the difference is between screen RAM and color RAM. Okay, so now it's tasting our ports, and there we can see user port 2, or user port is listed as bad. It sounds like there's a bit of an issue there with the Sid chip as well. But definitely, yeah, we're getting a bad on U2 for the user port. So at some point I have to take this out and socket it and then put a different one in and retest it. Originally the test did show that this chip here, which is just a MUX, it's a 4066 U28, it's literally just a switch. That was faulty, so I replaced that. So we turn it off now and we'll flip the switch to put it onto dead test, and we put it on again. Okay, and yeah, the SID sounds perfectly fine on the dead test. Obviously this doesn't test the 6522s because yeah, this just tests the core machine, but yeah, everything else seems to be working. Even the count in the for the timers on the 6526s, that's working fine. I mean, that can be an indication of a bad chip if those counters are not moving, but everything is fine. So yeah, it just goes to show you that the machine can look like it's working perfectly fine but still have a fault on it without the actual diagnostic harness, unless you actually try to do something with that port. In this case it says the user port is bad. You wouldn't know there was anything wrong. I mean, if somebody was selling this on eBay, they'd plug it in and say, oh, it comes on, it looks fine. You just don't know. It's certainly something where the test harness is invaluable. So let's just turn this off and we'll take a look at this other bread bin. Okay, so we'll go for diagnostics first of all. Okay, so it's testing the RAM. RAM test 1 is fine. Yeah, PLA test is saying it's okay. Testing the color RAM. This is the machine where I replaced the RAM chips. Okay, and it's also saying that U2 is bad on this, which is strange because the other day it was saying it was fine. Okay, Sid Chip's fine, but it's strange that it's saying now that U2 is bad on this machine as well, when it was perfectly fine the other day. So maybe something is amiss there. Okay, so let's try switching these chips over. When you're working on a board, usually touching the board itself is fine, but if you want to actually start taking chips out, then you need to wear an anti-static wrist strap. Probably not the best way to remove a chip, but you know, needs must. Come on. There's a problem with that chip. If it says then, if it still says U2 is bad, then yeah, I'm not too sure what's going on there then. I think the PLA chip just died. Let's try dead test. And we're getting nothing. Absolute zip. Which is odd. Ah, there we go. We're getting flashes. I do believe the PLA chip just died whilst filming. It was marginal before. As you saw, the machine the diagnosis started running and the screen went garbled and then nothing. Yeah, it is. The chip is now getting very warm. Okay, let's remove the diagnostic cartridge. And nothing, blank screen. So there you have it. It was a marginal PLA, now it's a dead PLA. RIP. Looks like I will be ordering some PLAs, because I actually have another board which is a slightly later revision than this, that also is in need of a PLA. Well, I never. So yeah. So if you let's take that off a second. So if you don't have any of this test equipment or other diagnostic tools, another good way is to check is if the chips are getting warm. If you touch a chip and it's like you have to pull your finger straight away because it's burning, that's usually a pretty good indicator that the chip is dead. Let's just pop this back on here. And we will dispose of you. This was a machine I recently picked up. It's very, very yellow. Somebody put this in as a reset switch and put this other huge, big toggle switch in here. I mean, you can see by the size of the hole. I mean, I can get my pinky in there, and I don't have small hands. Number 6 key's broken. A few of the other keys are chipped. But, you know, I just use it as a test machine. This is actually a slightly later revision board. This is 250425. The other one was a 407. And the main difference is the circuitry for the VIC2, the clock chip, clocks and timing and everything is greatly reduced. You've got one chip and the VIC2. The other noticeable change is that on the other machine the PLA is here and the SID is here. On this one, this is the PLA and this is the SID. Also, you can see that you know, the circuitry here. If I just bring another one of these back in, you can compare the two. So you can see the difference. Obviously, yeah, you can see that you know, the circuitry around here is greatly reduced on this one. You haven't got this big, huge choke, which for some reason, whenever I see these, even on all my machines, the tops of these are always chewed up. It's just like when they manufactured the board, they must have just stuck them on top and the pins must have gouged on there because it's the highest point in this area. So you can see that there's comparably less electrolytic capacitors. I mean, just here alone you've got 1, 2, 3, 4, and here you've got 1. Okay, here you've got a little tactant. You got these here, we're on here, none. So obviously, you know, this was slightly more cost reduced. You got a transistor here, whereas you don't have it here. You got some bodged in diode there. So other than the SID, and which I pinched to put in another machine, this one had a dead PLA chip. I recently did a repair video on this. If you take a look on my channel, and yeah, literally I just switched it on and I just touched the chips. I touched that one, it was burning hot, so instantly I knew. Oh, actually this one, sorry, that's the SID. instantly I knew that, yeah, the PLA was gone, because it was just so hot. So I took the PLA, the one that just died, off that board and put it into here, and yep, it worked fine. Up until it just died. For reliability, the better machines to go for, especially if you're a hobbyist, or not somebody even a hobbyist, you just want to get into retro and have an old 8-bit machine to have a bit of fun with, is to get the C64C, because these machines are considerably more reliable than the older bread bins. If you can get a bread bin with a Signetics PLA, then usually those are pretty rock solid. But otherwise, yeah, the Moss ones, they're always going to be a bit flaky. Let's just pop the lid off this. Now this is an earlier C64C. You can see, if you are an Amiga owner, you'll recognize this, the keyboard latching underneath, lugs on the front of the case. On this one, there is a metal shield. Unfortunately, I can't do away with the metal shield because they also hold the keyboard, all the keyboard brackets. I suppose this one could probably self-support itself, but this one can't. Without the actual shield itself, it would just, yeah, it would just collapse. This one probably would as well, because there's only that thin thing there. On this machine I have a SD to IC, an internal one built in, so I just have the SD card sticking out of there discreetly. Most of the common thing on these machines is that the Sid Chip, this is an 8580 R5, and the VIC-2 chip on all these machines are generally socketed. That's why you'll see a lot of times that those chips have been pilfered, and they just sell the rest. They take those 2 chips because they're quite valuable. They tend not to take the other chips because the people doing it are just scalpers. They don't have any skills to remove the other chips, like the 6526s or the CPUs, which are soldered, so they don't even bother. They just literally just rob out the socketed chips and move on, and then just try and sell the rest for as much as possible on eBay. This is a later SID, obviously, it's an 8580. There are differences in the sounds between the two. The purists will say, obviously, in the earlier SIDs are the better. Some people say the 8580 are the better. And yeah, you can create a track, some music for the older one, and play it on this, and it will sound terrible, and vice versa, because there are differences in there. This has the what's known as the Super PLA. This is a Commodore branded one, but again, these things are pretty rock solid. One thing to note is that the RAM chips have been reduced from 8 chips down to just 2 chips, and overall there is considerably less chips. This is known as a shortboard. A lot of the glue logic that was on the other board in discrete chips has now all been included within this PLA, and here we have our color RAM. And yeah, there isn't a huge amount more. It's certainly a very more minimalistic machine. So let's hook up the old dead test and fire that up. I'm not sure what's going to make with the SD to IEC plugged into there. It shouldn't cause any issues as far as I know, because yeah, obviously this I can't just disconnect it because it's soldered into the board. Now to me that SID sounds exactly the same as the other. Yep, and that's totally fine. We'll switch it over to dead test. Yep, and that tests fine. Okay, so I do have one more C64C to look at, and this was probably one of the latest ones that came off the production lines, because this one is a greatly cost reduced one. If we flip it over, we can see instead of having screws for the cases, we have these plastic tabs. This one's made in China, and this one is actually called the C64E. So is the other one. The other one has a sticker that says C64E on the inside, but yeah. And let's just unplug that. And a big difference with this is obviously there's no metal shield. There is no keyboard mounting brackets. The keyboard actually is held in by clips on the underside of the case here, so, and does come out rather too easily. The actual board itself is pretty much the same. There aren't a huge amount of differences between the two, but the notable difference is that the video RAM chip here is now been integrated into the Super PLA, and this Super PLA is a sharp one. And yes, unfortunately, when these go bad, they're pretty hard to get hold of. But luckily, they don't go bad very often. Usually, if that's gone bad, it's probably due to somebody connecting a bad power supply to it. I do have a board. This is the same revision board, I do believe. Yes, yeah, this is a same revision board. I picked this up off eBay for €15 plus shipping. I think it was about 18-19 euros in total. Yeah, the Sid chip was missing, obviously, and also the VIC-2 chip and the clock chip. The rest was there and actually soldered. All these sockets I fitted afterwards. In fact, all the chips, with the exception of the Super PLA, have been socketed, so I could test them. As you can see here, I didn't have a 24-pin socket, so I just cut a few pins off a 28. So yeah, I took a punt on this one. That, you know, it was just somebody had pilfered the chips on it and then decided to sell the board. But unfortunately not. When I plugged this in, the first thing I noticed was that the CPU was getting rather hot, far too hot. So I desoldered that, then plugged it in, didn't put anything else in just to be on the safe side. I didn't want it frying anything else. And then, yeah, the character ROM then got very, very hot. So I took that off, plugged it back in, then, you know, the combined basic kernel ROM, that started to get in very hot. So I replaced that as well. And then, lo and behold, same thing with the 265 26s. So yeah, I literally replaced a lot. I put in all known working chips and the board still didn't work. So I then took out all these support chips and tested those in case one of those was faulty. They all actually tested fine, which is strange that everything else didn't. So yeah, then the only suspect then is this Super PLA. Obviously, somebody plugged in a power supply that's bad on there, and yeah, just sent probably 10 volts through the board and just fried all the chips. They plugged it in, turned it on, and went, "Oh, it's not working." They probably took off the Sid and the Vic, put them off the side, and then decided to sell the board. So there's a high probability that the VIC and the Sid chip were also fried. So yeah, karma. That's all I can say. The only thing I don't like about these cheap capture devices is it always puts the source and the input and the output message up there and on the OSD, and it stays there for like 20 odd seconds. It was there for 2 or 3 seconds, maybe 5. Yeah, but it's annoying. Now it's gone. Okay, so far so good. Testing the color RAM. Serial port's not, dongle's not plugged in. So of course it's going to say serial port is bad. Where did I put that? And did I leave it attached to the other machine? Oh, there it is. Okay. So 0 page is okay, stack is okay, screen RAM. Okay, RAM test 1. Okay, RAM test 2. And color RAM. Yep, so all fine. Kernel, basic, and character, cassette, keyboard, everything. Perfect. So I'd like to give a big shout out to Sven Peterson for building such a great diagnostic harness, so the rest of us don't have to. I could have built one myself. There's plenty of schematics out there on. Sven's done, a brilliant job, and also he 3D printed these 2 cases. This is just using a normal, I think, off-the-shelf cartridge case, and yeah, made up all the cables. I also have the C128 diagnostic cartridge here, which I will be testing in one of my upcoming videos, because I just got hold of a C128 flat, which is in a pretty sorry state, so that'll come in handy there. I also like to give a big shout out to Transmission 64 for inviting me to do this video for them. I hope you enjoyed the content and found it useful, and hopefully it'll inspire some of you to go out and maybe pick up a C64 and do a bit of tinkering, have a bit of fun. As always, thank you for watching.